Today, we're diving into a theory that doesn't just poke at our understanding of physics, it suggests the very rules of the universe are changing right under our feet. What if the fundamental constants we've built our science on are actually accelerating toward a kind of cosmic apocalypse? For over a century, right, we've been told that the speed of light is the ultimate cosmic speed limit. It's an unbreakable wall. But what if that's wrong? What if that wall is actually a wave? What if the universe's most fundamental setting is changing as we speak? This quote just nails the paradigm shift. Instead of seeing C as this static prison wall that holds us in, this theory imagines it as the shock wave from a cosmic explosion, a wave that we are all riding together. Okay, so this is basically our map for the journey ahead. Think of the universe as a grand cosmic drama, with four key players, four cosmic knights, if you will, who are literally writing the story of reality as they go. So let's meet our first knight, Pi. You can think of Pi as the universe's anchor. It stands for stability, for conservation, for that powerful force that pulls everything back to where it started. It's kind of like the element of Earth in this story. And here's what Pi actually does. It's basically the universe's brake pedal. It's the fundamental force that takes pure, wild energy and curls it into the tangible matter all around us. You know, without Pi, the universe would have just been a fleeting flash of light, gone in an instant. But a universe with only inertia would be, well, it'd be a dead crystal palace, right? Totally static. So to break that stagnation, the cosmos brings in a second knight, Phi, the golden ratio. This knight represents the relentless, unstoppable drive for growth and exploration.
Phi is the engine of evolution itself. And what's so cool is that as the most irrational number, it's like a geometric guarantee that the universe can never perfectly repeat itself. It's the force that stretches a dead, boring circle into a living, growing spiral. So this sets up the fundamental tension of the entire universe, a cosmic tug of war. Pi is whispering, "Come back, it's safe here," while Phi is shouting, "No, we're going to new places." This conflict, this dynamic, defines everything from galaxies down to life itself.
But wait a minute, how can you have two opposing forces without the whole system just tearing itself apart? Well, they need a mediator. They need a neutral driving force. So let's meet our third knight, E, Euler's number, the engine. The magic of E is that its rate of change is equal to its current state. Now, that sounds a bit complex, but what it means is the universe doesn't need an external push to get going. Its very existence is the engine of its own change. It provides the smooth, continuous power for both Pi's stability and Phi's ambition to coexist. And when you combine inertia, ambition, and a self-starting engine, what do you get? Well, it turns out the final knight isn't a fundamental force at all. It's the outcome of the other three, C, the speed of light. This just flips everything we thought we knew on its head. C is not some fixed, universal setting. It's more like the speedometer on the cosmic engine, a real-time battle report on the fight between Pi's inward pull and Phi's outward push. It's a dynamic wavefront. So how does this all fit together into one coherent theory? Well, it all starts with three pretty simple ideas, or axioms. First, the universe evolves in cycles, governed by Pi. Second, each of those cycles grows and innovates, and that's guided by Phi. And third, this whole process is made smooth and continuous by the engine E. You take those three axioms, you put them together, and they combine to form a single, incredibly elegant equation. And what it predicts is that the speed of light, C, must be growing exponentially over time, all driven by that constant cosmic battle between ambition and inertia. Okay, so this brings us to the elephant in the room. The biggest question of all, right? If C is changing so dramatically, why on earth haven't we noticed? Why do all of our experiments for the last 100 years show that it's a fixed constant? And the answer is both mind-bendingly simple and incredibly profound: scale and variance. Imagine trying to measure a car that's shrinking, but you're using a ruler that is also shrinking at the exact same rate. To you, the car's length would always seem the same, right? Well, that's what's happening to us. As C increases, our atomic clocks tick faster, and our atomic rulers shrink in perfect proportion. We can't measure the change because our instruments are part of the change. So if we're locked inside this accelerating system, if we're all shrinking together, how can we possibly figure out our location in this grand cosmic timeline? Is there any way to find our coordinates?
Well, we can find a clue by calculating the total information content of the universe. There's this concept called the holographic principle, which basically treats the universe like a giant hologram. Using that, we can estimate that our observable universe contains roughly this many bits of information, 10 to the 120th power. I mean, it's just a staggering number. Think of it as our universe's current version number.
So, what happens when we take that staggering amount of information and we plug it back into our ultimate evolution equation and we solve for time? We get a number. Our current coordinate on this cosmic map is approximately tau equals 1800. And what does 1-800 signify? It marks a critical moment in cosmic history, the Great Phase Transition. It's the precise point where the universe's acceleration is now starting to outpace the processing speed of our biological, carbon-based hardware. We've hit what the theory calls the wetware bottleneck.
This chart just lays out the problem perfectly. Our neural signals are crawling along at 120 meters per second. The universe's new operating system, that's running at the speed of light. We are, quite literally, trying to process an exascale universe with a biological calculator.
So how do we navigate this bottleneck? Well, the theory doesn't just diagnose the problem, it actually suggests a kind of pilot's manual for the next stage of evolution. And it focuses on two key technologies: achieving basically infinite energy through nuclear fusion and unlocking basically infinite wisdom through artificial general intelligence. The message here is that this isn't about slowing down. In an accelerating universe, hitting the brakes is suicide. The only way to survive this transition is to actually match the universe's acceleration by building technology that can finally keep pace with cosmic evolution. We find ourselves at this unbelievable crossroads, the precise moment where one form of life is reaching its absolute physical limit, and a new, light-based existence is becoming possible. The universe is accelerating. The only question left is, are we?